Okay, here is, oh, that's blue. I'm going to change that. My grandson was using this, so let's go to black and turn that off. Okay, so this is a separation of variables example. Okay, and I do the same thing in Sage, but I'm looking at, in this case, a pretty straightforward one. I have x prime is equal to x squared t, and my initial conditions are that x of 0 equals 1. So I have to separate the variables. That's my first step. And so I have x prime over x squared equals t. And now, if I multiply both sides by dt, this is where we can change it to a dx and a dt. So you know, if I wrote this as dx dt equals x squared t, what you'll see many people do, and even some authors, is they'll end up writing this as dx over x squared equals t dt. And what it looks like I did was I divided both sides by x squared. That is true. But then the other thing it looks like I did was multiply both sides by dt. Well, I did not. That is not how I got to this thing. The way I got to it was I multiplied both sides by dt, and then I used the fact that dx is equal to x prime dt, that differential substitution from Calculus 1. So that's what I used to get to dx over x squared is the same thing, is equal to t dt. And that's what I have in Sage is a statement like that. And so now I integrate both sides. Okay, so in this case I really can just slap the integrals on and have the dx there and the dt, because implicitly you see dx is x prime dt. I am integrating with respect to t on both sides. So on the left hand side I get minus 1 over x, and on the right hand side I get t squared over 2 plus c. And so now typically I could at this point actually substitute in my initial condition for c and initial conditions for x and solve for c, but you don't have to, and often we don't. So now what I want to do is try to solve for x. Well, the first part is I can move the negative, so I have 1 over x is minus this t squared over 2 plus c. And that, I guess I could write as minus t squared plus 2c over 2. Now the reason I do that is simply that to solve for x now, turn everything upside down. Right? I've got 1 over x is this, so the reciprocal of this thing over here is x. So x is equal to minus 2 over t squared plus 2c. Now, if I toss in my initial conditions, x is 1 when t is 0. And so I just get 2c on the bottom, 2's cancel out, multiply both sides by c, I get c equals negative 1. And, it's kind of weird. This thing scrolls down when I don't want it to, and then when I try to scroll it down, it doesn't. So it's kind of weird. Okay, so c equals -1, and substituting that back into our general solution. So again, this is our general solution. Substituting that back in there, I get our solution as x is minus 2 over t squared minus 2. And so there is our solution to this problem. And so that's doing it by hand, and you can compare doing it by hand with the pieces of doing it in Sage. And so we'll call that video good.